An electrode is modeled as a voltage source and a resistor or impedance. The voltage source in the electrodiagnostic studies is the electrical activity generated by nerves and muscles. The impedance is usually indicated by letter Z. It is a measure of the contact between the recording electrode and the signal generator. If the contact is poor, the impedance will be high. When the electrode is connected to the amplifier, we will lose some voltage Vz in the impedance. The voltage appearing at the amplifier input will be less, V minus Vz. To minimize this voltage loss Vz, the electrode impedance should be low. To record a potential, we need 3 electrodes: active, reference, and ground. All of these electrodes should have low impedance. Furthermore, the impedance of the active and reference electrodes should be similar. High impedance or mismatched impedance gives more noise and artifacts. In nerve conduction studies, the recording electrodes are placed over the skin surface. If the skin is covered with oil or lotion, which are bad conductors of electricity, the impedance will be high. Hence, one should clean the skin surface before applying the electrodes. Many laboratories use alcohol-soaked gauze pads for this purpose. A layer of dead skin cells also gives high impedance. One can use abrasive paper or gel to remove them. One should be gentle when using abrasive material and not harm the patient. Next, conductive gel is applied to the reusable electrodes, and they are secured over the skin surface using sticky tape. The disposable electrodes are pre-gelled and do not need any additional application of the conductive gel. With repeated application and removal of these electrodes, the surface will be contaminated by dirt and other material. This will not only affect the adhesive properties, but also increase their impedance. In my experience, these electrodes work quite well for 6 to 8 applications when proper techniques are used. The electrode impedance is less at higher frequencies. Since different electrodiagnostic systems use different frequency signals to measure impedance, the absolute impedance values for the same electrode can be quite different on different instruments. In general, I do not measure the electrode impedance in routine nerve conduction studies. A relatively flat signal baseline is indicative of proper electrode application. In evoked potential studies, the potentials are much smaller, often less than 1 or 2 microvolts. In such recordings, impedance measurements are a standard operating procedure. One should also make sure that the impedances are low and similar. For the concentric needle, the active recording surface is in the needle tip. The cannula serves as the reference electrode. Both surfaces are intramuscular and surrounded by highly conductive body fluids. Hence, they have low impedance. Therefore, concentric needle recordings usually have low noise. They are preferred for quantitative analysis. In monopolar needle EMG, the active recording surface is intramuscular and has low impedance. A surface electrode is used as reference, and it has relatively higher impedance. Due to the impedance mismatch, the monopolar needle EMG recordings are more sensitive to noise and interference. The single fiber EMG electrode has a very small recording surface, only 25 micron in diameter. This gives it high impedance despite being used in intramuscular manner. The cannula, which serves as the reference electrode, has low impedance. This impedance mismatch also makes single fiber EMG recordings sensitive to noise.